Hello everyone! I've been working on this project on and off for a while now, and I finally got to a proper prototype that I wanted to show off. So this is a 3D printed, compliant mechanism, velocity sensitive optical switch MIDI keyboard, or at least one octave of it. So let's go over what that means. Broadly speaking, it's a MIDI keyboard, meaning that it's a piano-like interface to play music on through the use of a digital instrument. If I open a VST over here, I can play music through it like this. Now, this keyboard is also velocity sensible, meaning that if I play harder and therefore move the keys faster downward, the sound gets louder. Although, not just louder, since some instruments include dynamics which change the timbre of the sound, but I digress. As I said, the keys are 3D printed and are also flexures, aka compliant mechanisms, aka they bend. However, this isn't your ordinary flexure key, which pivots at the back. No. This is a 4-bar linkage that mimics the movement of a key which pivots 26 cm from the tip, modeled after my upright piano here at home. As you can see, if I press the back of the key, it also depresses down. This mechanism allows for much more comfort when playing, like a longer pivot would, but keeping the footprint of the action within the playable part of each key. You can see it doesn't stick out further back than here. At the beginning, I also set this as optical switches, which means that the part that actually senses the position of each key is light activated, hence all these LEDs. And there's even more on the inside. Now, for this, I'm using photoresistors, 2 of them per key, and the velocity, as in loudness, of each keystroke is calculated based on the time interval between blocking each sensor. Now, photoresistors will work fine if it weren't for the fact that they tend to be very inconsistent in sensitivity, which results in some triggering early or late, leading to more or less sensitive keys. This is unacceptable, since I want to use this keyboard as my main instrument and want it to actually be properly playable. Right now, I'm waiting on some phototransistors from AliExpress, hoping that this can solve my issues with consistency. Let's talk a bit about electronics. I'm using 2 microcontrollers, both powered by an RP2040. This one is programmed in micropy and is in charge of talking with the computer. It presents itself as a MIDI device and sends note information through USB-C every time a key is pressed. This other microcontroller is programmed in the Arduino IDE and is in charge of actually monitoring every key. To actually read so many switches, just 24 in this prototype, but I plan on the final one having 98, I'm using a keyboard matrix with N key rollover, hence all these diodes. Now, I won't go into more detail about what that means, but there's plenty of information out there. I am a bit concerned on whether or not this little Raspberry Pi Pico will be fast enough to read all those keys while keeping sub-millisecond precision on the interval of each key press, but only time will tell. The Pico talks to the other controller through serial, although just in one direction. You can see this single bent wire, which carries the information. For the future, I have plenty of upgrades planned, from little tweaks here and there to bigger quality of life changes that will greatly improve the experience of assembly, since this prototype was already a nightmare to assemble. If this video gets any attention at all, I'll probably make an update video once I have the next version of this single octave ready, but no promises as to when that might be. Thank you for watching, and I hope to see you again.